Hello, this is Professor Mitchell, and this is the first of two parts of section 4.6, Graphs of Other Trigonometric Functions. In this video, I'm going to talk to you about the graphs of the tangent and cotangent functions, and then in part 2, I'll talk about the graphs of the secant and cosecant functions. So the objectives in this video are going to be to understand the graph of y equals the tangent of x, graph variations of y equals the tangent of x, and then do the same thing for the cotangent of x. So here you see a table of values for a y equals the tangent of x. X is going from 0 to pi over 2. Let me point out that these first few values, 0, pi over 6, pi over 4, pi over 3, it's a good idea to try to memorize the tangent values at those angles. Those are the angles in quadrant 1. These other values you see here, 5 pi over 12, 17 pi over 36, etc., don't worry about those. Those were evaluated with a calculator just to fill in some more points on the graph. Notice over here that the tangent of pi over 2 is undefined, and that's because the tangent is the sine divided by the cosine, and the cosine of pi over 2 is 0. And whenever you try to divide by 0, the result is undefined. So when those points are connected with a smooth curve, what you get is what you see here, starting at the origin and going to the right. And then because the tangent is an odd function, this graph has origin symmetry, and so that graph is mirrored through the origin, and you get what you see over here. And again, the tangent is undefined at x equals pi over 2. So at x equals positive and negative pi over 2, you have vertical asymptotes. Characteristics of the tangent curve: the period is pi. Notice that, for example, the interval from negative pi over 2 to pi over 2, that has length pi. And whenever you complete an interval of that length, the graph just repeats itself over and over. The domain of this function is all real numbers except for odd multiples of pi over 2. Those are all the values that are going to make the tangent undefined, because the cosine will be 0 at all those values. And the range is all real numbers. If you pick any y value, you can find actually an infinite number of points on this graph that have that y value. More characteristics: so you have vertical asymptotes at all of those values where the function is undefined, odd multiples of pi over 2. You have x-intercepts midway between each pair of consecutive asymptotes, and that would be at multiples of pi. So notice at 0, pi, 2 pi, negative 2 pi, the tangent is equal to 0 at all those points. Again, it is an odd function, and I'm not going to talk too much about this last bullet point here because that'll come out automatically when I show you how to graph a tangent function. Okay, so what you're going to see here should look really familiar if you watch the video, my video for 4.5, graphing sine and cosine functions. I'm going to use almost exactly the same steps. They're just a little bit different with tangent. Okay, so one place where it's different is that the period of this function is pi over b. If you have a sine or cosine function, the period is 2 pi over b. So that's one thing that's different. To graph one period of the function, we're going to construct a table just like we did with sine and cosine. Here's another thing that's different. We're going to start the table at the value of x that makes bx minus c equal negative pi over 2. So with sine and cosine, we started at the value that made bx minus c equal 0. So tangent is the only function of the four, sine, cosine, tangent, cotangent, where you set that equal to anything other than 0. And then, just like with the sine and the cosine, we're going to go in increments of period divided by 4 until we have a total of 5x values. And for tangent, notice that the tangent will be undefined at the first and last x values, and the graph will have vertical asymptotes there. So you'll see that happen in the example. Then we're going to evaluate the function at only the middle three x values technically, because again the function will be undefined at the first and last x value, and we'll have vertical asymptotes there. And so then we'll have a set of points. We'll have 3 points and 2 vertical asymptotes, and that will enable us to draw one period of the function. And then if they ask you for more than one period, we can extend the graph to the left or to the right. Okay, so here's a picture of what a typical y equals a times the tangent of bx minus c looks like. And you don't really have to pay too much attention to all those details because they will come out automatically if you follow the 5-step procedure that I just described. So let's look at an example. We're going to graph the function y equals 3 times the tangent of 2x over the interval from negative pi over 4 to 3 pi over 4. So let's go through the steps. Notice that a is 3, b is 2, and c is 0. First we're going to find the period. So notice that b equals 2, and that means that pi over b is going to equal pi over 2. That's the period. Step 2, we're going to find the x values for the table. So to find the first x value, we set bx minus c, which in this case is just 2x. It's whatever's being put into the tangent function. We're going to set that equal to negative pi over 2. So when 2x equals negative pi over 2, you divide both sides by 2, and that means x is negative pi over 4. We're going to start our table there, which is nice because that's also the beginning of the interval that they wanted us to graph it at. We're going to go in increments of period divided by 4, which in this case is pi over 2 divided by 4, which is pi over 8. Okay, so now some fun with fractions. The 5x values are going to be negative pi over 4, and then add pi over 8, and that gives you negative pi over 8. Add pi over 8 again, and you get 0. Add pi over 8 again, you get pi over 8, and for the last one, you add pi over 8 one more time, and you get pi over 4. So on the next slide, you're going to see the table that's going to have these 5x values, and I'm going to plug those 5x values into the function. Unfortunately, I could not get the animation on this one to work quite as well as it did in 4.5. And if you watched 4.5, you might remember that I kept asking you to pause the video so that you could try to calculate those y values yourself. So I'm going to say it now. If you would like to try to set up the table and plug these 5x values into this tangent function, y equals 3 times the tangent of 2x, go ahead and do that now. On the next slide, the table is going to come right up and it's going to be all filled in. So I won't be able to pause the way that I did in 4.5. So here it comes. So you see those 5x values, and when you plug them into the tangent function, the first one, negative pi over 4, the tangent of negative pi over 2 is undefined, so that's going to be our first vertical asymptote. The second one, when you plug in negative pi over 8, that gives you 3 times the tangent of negative pi over 4. The tangent of negative pi over 4 is negative 1. And so that makes this negative 3, so we have a point at negative pi over 8 comma negative 3. Then we plug in 0. The tangent of 0 is 0, so this graph is going to go through 0, 0. And then plug in pi over 8. You get 3 times the tangent of pi over 4. The tangent of pi over 4 is 1, so that makes this equal 3. We're going to go through the point pi over 8 comma 3. And then finally, if you plug in pi over 4, you get 3 times the tangent of pi over 2, and like we were saying earlier, the tangent of pi over 2 is undefined. So that's going to be our next vertical asymptote. So right here, this first one here, this is what you would get if you connected those 3 points and also incorporated the vertical asymptotes. Over to the right here, this is the result of step 5, where we extended the graph just to get the entire interval that they asked for. Remember that they asked us to go all the way up to 3 pi over 4. So our table only went up to pi over 4. So we just drew one more period of that function. So now let's talk about the cotangent. The graph of the cotangent function is kind of similar to the tangent function. It also has a period of pi. The domain is a little different. The cotangent is undefined at multiples of pi, integral multiples of pi, which means integer multiples. So you see here 0, it's undefined at 0, it's undefined at pi, undefined at 2 pi, etc., etc. The range is also all real numbers. This graph extends infinitely up and infinitely down. So we're going to have vertical asymptotes at all of those values where the function is undefined. We have an x-intercept midway between each pair of consecutive asymptotes. So that would be at pi over 2, 3 pi over 2, odd multiples of pi over 2, negative pi over 2. This is another odd function. You may recall from earlier in the chapter that the only two trigonometric functions that are not odd are cosine and secant, and they're actually even. All of the other four trig functions, sine, tangent, cotangent, and cosecant, are all odd. And this last bullet point, we won't pay too much attention to that. Okay, so this is going to look really familiar to you. It looks just like the 5 steps for the sine, cosine, and tangent. One little exception from tangent. So first of all, the period is pi over b, just like tangent. To graph one period of the function, we're going to construct a table. We're going to start the table at the value of x that makes bx minus c equals 0. So remember, for tangent, we set bx minus c equal to negative pi over 2. And that's the only trig function that we do anything different from 0. Sine and cosine even, you set it equal to 0. Go in increments of period divided by 4 until you have a total of 5 x values. Note that the cotangent will be undefined at the first and last x values, and the graph will have vertical asymptotes there, and that's exactly what happened with the tangent. Evaluate the function at the middle 3 x values. Technically, we're not evaluating it at the first one and the last one because that's where the vertical asymptotes are. Plot the points in your table, connect them with a smooth curve, indicate the vertical asymptotes with dashed lines. And then if they ask you for more than one period, you just extend it to the left or to the right. So here again are more details about the graph of a cotangent function, and all of this stuff will happen automatically when we follow the 5 steps. So let's look at this example. We're going to graph y equals 1/2 cotangent pi over 2x. A is 1/2, b is pi over 2, and c is 0. So first we're going to identify the period. B equals pi over 2, which means the period is pi divided by pi over 2. And of course, dividing by pi over 2 is the same as multiplying by 2 over pi. So that comes out to 2. The period is 2. We're going to find the x values for the table. Remember that in a cotangent, we're setting bx minus c equal to 0. So we're going to set pi over 2x equal to 0, which means x equals 0. And we're going to go in increments of period divided by 4, which comes out to 1/2. So that's going to give us some nice x values to work with. And those x values are going to be 0, 1/2, 1, 3/2, and 2. We're just going up in increments of 1/2. So coming up in the next slide is our table. We're going to take the values 0, 1/2, 1, 3/2, and 2 and plug them into this function. Y equals 1/2 the cotangent of pi over 2x. If you would like to try to construct that table, pause the video here and then check your work on the next slide. So here comes the next slide now. Again, sorry, couldn't get the animation to work as well as 4.5. All right, here it is. So we take the values 0, 1/2, 1, 3/2, and 2. We plug those values into this cotangent function, y equals 1/2 the cotangent of pi over 2x. And first we get 1/2 times the cotangent of 0, which is undefined. Remember, the cotangent is the cosine divided by the sine. Sine of 0 is 0. And whenever you try to divide by 0, the result is undefined. So that's our first vertical asymptote. Then we're going to plug in 1/2, and that gives us 1/2 times the cotangent of pi over 4. The cotangent of pi over 4 is 1, so that gives you 1/2. Our graph is going to pass through 1/2 comma 1/2. Then we plug in 1. The cotangent of pi over 2 is 0, because it's the cosine divided by the sine, and the cosine of pi over 2 is 0. And when you have 0 on the top of a fraction, that gives you 0. So we're going to go through 1, 0. Then we plug in 3/2, and that gives you 1/2 times the cotangent of 3 pi over 4, which is negative 1/2. And finally, we try to plug in 2. That gives us 1/2 times the cotangent of pi. The cotangent of pi is undefined because the sine of pi is 0, and that's what's on the bottom of the fraction. So we're going to plot those 3 points and those 2 vertical asymptotes, and what you get looks something like this. So going from 0 to 2, and then this is just a little extra over here. We technically didn't need that. They didn't ask for us to graph it over any specific interval. So in that case, you could just do 1 period. Just go from 0 to 2. And so that's going to conclude what I have to say about graphing tangent and cotangent functions. So next will be part 2 of 4.6, which is graphing secant and cosecant functions. Thank you very much.